Hello everyone, welcome to SNDev. And in today's video, we are going to learn about the fundamental elements of LangGraph. Okay, now I have made one LangGraph video before, and many of you asked me to build some industry-based LangGraph AI agent application. Now I have already working on that, but before I publish the video, I wanted to explore and explain the fundamental elements and how to build a LangGraph AI agent and how to build a workflow. Okay, so that's what I'm going to do in this video. So in this video, first of all, we'll explore the fundamental elements of LangGraph, and then we'll build a support board that will simulate all the key concepts or element of LangGraph. Okay, now, but instead of giving you a textbook definition, I'm going to explain LangGraph using something fun and relatable, like an escape room analogy. Okay, so yeah, let's begin. So first, what is LangGraph? So LangGraph is a Python framework that let us build AI workflows as graphs. And you can think of it like designing a flowchart where each step or node can use LLM, a tool, or our own logic. And it's especially useful when you want more control than what simple chains or agents can offer. Okay, so before I explain you with the escape room analogy, so first let me set you up. So let's imagine you are in an escape room and you move from one room to another solving puzzles. Okay. Along the way, you carry a backpack where you store your clues. Some rooms might give you tools like some flashlight or some key, and based on your decisions, you move forward or back. That's exactly how LangGraph works. Okay. So now let me break it down. Okay. All right. So now we'll look into our different elements of our LangGraph. So let's begin with our first element, one of the most fundamental element, which is state. Okay, I'll minimize it a bit. All right. So what is our state? So a state is a memory or a context carried throughout the graph, and it can be updated at each node. Right now, as per our escape room analogy, our state would be our backpack. So think of it like our childhood backpack where we are getting into an escape room, and each room we are entering, it kind of adding some clues or tools, some gadgets to our backpack that we might use in our future steps. Okay, and we have to carry it to our next room until we are finishing the escape room game. Okay, and as for the context of LangGraph, you can think of it like a dictionary, or more of a custom class of LangChain type dictionary for a better structured state formation. Okay, and for a simple example of how it looks in a code, you could see we'll be defining a state like this, a class of state, and this name can be as per your wish. I have given here as support state. You can give it as agent state, state support, state agent, whatever you feel. Then it will be a type dictionary. Then it contains of two types of information. For this code, it has a message and an issue type. Okay, it can be anything as per your requirement, right? And don't get confused with this literal as billing technical. You will understand while we'll code this our when we'll code our support bot. Okay, all right. So after that, our second elements comes our nodes, which is the rooms. So what is nodes? It is a function or a step defined by us that does something with the current state and returns an updated state. Again, with the analogy, you could think it like a room in the escape room, and each room performs a task like solving a puzzle, giving you some clue, and based on the result, you move to the next room, right? And in LangGraph, nodes can be in the form of some regular Python function using that def keyword, and it could be tool nodes or even LLM based decisions. Okay, now for an example, see this block of code. Here I have defined two nodes of greet the user, of def greet node, which is kind of returning me a support state. Why? Because see, I have to return an updated state. I'm not returning any string or any integer or this kind of thing. I have to return a new updated state. Okay, So here I have the greet the user state and the classify issue node. Okay, and here you could see we have this building technical unknown which is a part of this code. Okay, now this is how we need to define our node. Now after state and node, third most important part is our edges, which is the doors. And these edges are the connection between our nodes, and they determine the flow of our graph's execution. And again, this edges references the doors in our escape room and these doors between rooms. And depending on what you discover in a room, you may take a door A or a door B. And here comes the part of that how many types of edges or how many types of door we have. So we have three types of edges in LangGraph. Conditional, like always go to the next step. Second is unconditional, where we have to go always to the next step. There is no here and there. Okay. Now second is our conditional edges, where we have to choose the next step based on some value in our present state. Third one is the multipath edges or the multiple output edges, where um, where we have to choose the next step based on the function returns the values. Like let's say if a state action if gives us the value of search, then we have to go to the search tool, right? So like this, our path will be defined by some conditions. Okay. Now after understanding what edges is, we have to understand our 2 point, our start and end. Okay, start is the entry point for our graph, and end will be our like when our whole processing stops. And for escape room, of course, like simple, its start is the entrance of the escape room and end is when you exit with the treasure or the solution. Okay, now after start end edges node graph, the most important and interesting thing is tools, right? So what are they? So these are like external APIs or functions the graph can call, and it can be any search tool like Tavily, SurPuppy, DuckDuckGo, or any mathematical API or any weather API, even any vector databases. So we can call these tools, and you can think of tools like a smartphone or a calculator you carry while solving the puzzles. You will pull them out whenever you need some help. Okay, and LangGraph often uses this LangChain tool over here. Okay, and with tools there comes another elements called tool nodes, which which are the special nodes that invoke a tool based on the current state. Okay, so you can understand a tool as a room where the only thing you do is the use of a gadgets or a tool, like a calling a friend for help or checking the GPS for the tracking of the rooms. Okay, like tool nodes is a particular node that lets you to call the web API. Like tools are the like tools would be my Tavily API key, my Tavily function, but tool nodes will be that particular node under which I'll be using that tools, that particular tool. Okay, and some example of tools you could see some tool function, this one for handling our billing and this one for handling our technical issues. Okay, and these are also returning the state, you see, support state. Okay, now after that we need to go to the final part, which is our graph and our state graph. What is graph? Graph is the entire chain of the logic collection of our nodes connected by our all the edges, which is like the floor plan of the escape room, which shows that how rooms are connected and in what order they must be visited, right? And state graph is more of a blueprint of the whole escape room. Here it is the object where you define the state nodes and how they are connected, right? And if you see the example, you could see graph, and you'll be calling your state graph and you'll be passing your state support state. Okay, and how to define a whole blueprint of a graph, we'll see that while we'll coding. Okay, now the last part is we have built everything, our whole agent is ready, our whole escape room is ready, but we need to press the play, or we need to give some signal that we can get into the escape room now. So runnable is that particular object, you can say, that the final graph object which you can call like a function. Okay, and you can think of it as a starting of the game. The setup is done, like the graph is done. Now you hit the play to begin your journey, and we use this runnable by just using this graph.compile function. So runnable graph.compile, and your graph is ready to go. And then you'll be using graph, and then we'll be using that invoke function to pass some values through our agent. Okay, so that was some references understanding of how what these elements are of LangGraphs, and this will help us to understand how to code LangGraph as per our requirement. Okay, now let's see a real example. And with this all key concepts, I have built a support bot, and we'll build the support bot together here, which simulates all these key concepts, and the support bots will greet the user. It will kind of classify the issue that user is having, or it is a billing issue, or a technical issue, and then our agent will route to the right tool as per the user's requirement. Okay, all right, so before we create the support bot with our all key component, let me create the simple AI agent bot. Okay, like the sim using our node, our state graph, all those components. Okay, so for that, first I need to install a couple of things. So pip install LangGraph, sure, then not comma LangChain, also that LangChain core, and we need what? We need graph viz for the visualization. Okay, so graph viz, it will be graph viz, this one. Okay, install. So all right, it's done. Now I need to install. So as I mentioned earlier, that we need to use that dictionary or that class or that custom object of type dictionary, right? So we need to import them. So from typing, I'll import dict, this one dict, sorry, dict, and type dict. So this one type dict. Okay, all right, then from langgraph dot graph, from here I need to import StateGraph. As I mentioned earlier, that StateGraph will help us to build the whole blueprint. Okay, here we go. Now the first step would be to define our state, right? So for that, class, and I'll define a state as, let's say, state agent. Okay, and here in state I'll pass my agent state. This one, sorry. So we are first defining a state, right? So a class of state with type dict. Now my state, like what information my state will contain, in this case a simple message. So sorry, a message spelling is message of a string str. All right, okay, I'll enter. That's it. Now after that I need to define my node, right? So dev, let's say the node name is greeting, and in my greeting node I'll pass the state. And what's my state name? My state name is state agent. And what I've said earlier, that my every node will return an updated state. So this should return the updated state agent. Okay, colon. Now like whenever you are using this LangGraph or MCP server, like whenever you're creating some application of agentic AI, you always, it's a best practice to always use the docstring. Okay, so this one. So here, what this greeting function does, a simple greeting node that adds a greeting message to the state. Okay, simple one. All right, now what this message will be, right? So in my state message, here I need to define that in which format I'll store the message, right? So let's say hey, then my not string, that state of message mean what user will give, then state message, then let's say hey, a name, then how are you? Okay, all right, and we'll simply return our state. Okay, I'll run this. So our node is done. Now after having the node, we need to define our graph. Okay, so for graph I'll use graph, and I need to use simple our state graph where I need to pass my state. So my state name is state agent. Okay, this done. Now defining the graph, we need to create the state graph like the blueprint. Okay, so for that, first I need to add graph dot, I need to add the first node, so add node, and here I use my only one node that I built, which is I think greeting, right? This one, greeting. Okay, all right, and what more node do I want? Nothing. I don't have any other node, right? So after that I need to define the entry point and the end point. So graph dot, to set the entry point I can use this one, set entry point, and here I'll simply pass which node I want. So it is my greeter. Okay, the spelling is wrong, greeter. Okay, now this is the entry point. After entry I need to fix the finish point. So graph dot set, here is the finish point, and for finish point you can also use greeter. All right, it's done. Okay, now I'll come over here. Now I need to compile the graph, right? So app dot graph dot, I'll use compile. Okay, enter. There is some error. It's saying key found age starting at unknown node greeter. Okay, so this name is wrong. Greeter. Now, all right. Now after the compilation, I need to invoke, like I need to use the agent, right? So in my result, I'll use the app, then the invoke. Here I need to pass the message. So the message, and let's say then dev. Okay, enter. Now to see the message, result of message. All right, you could see hello SNDev, how are you? There is no space, so for that I have to change this one. So a dot, then a space. Okay, now run every cell again. Okay, hi SNDev, how are you? All right, now one more thing that we have to know, what like whenever you build any LangGraph application, you should always print its workflow. Okay, so for that I'll use from IPython display. From IPython.display we have to import image and display. Alright, then under display function I need to provide my image, and here I'll use this app dot this get graph. So this get graph function, and then dot simple draw mermaid png, which is a function. Okay, simple enter. You could see a start node, a return node, and an end node. Simple. Okay, so that's how you build a simple agentic graph, like a simple agent. Okay, all right, so now for that support bot, where we'll be having a much more complex routing with conditional edges, much more tools, nodes, everything. Okay, and of course I'm not using any LLM or any vector database. It's just like how to use those all elements. Okay, so first let us import. So from LangGraph dot graph I need to import what? From LangGraph dot graph I need to import our state graph, and the end node. Okay, then from typing I need to import dictionary, typed dictionary, so type dict, and as you saw, let me just show you the actually draw. You could see in our state graph we have, in our issue type we have literals, so we need to import literals as well. Okay, so type dict, sorry, from typing there will be import. Okay, so dict, type dict, and we need to import literal. All right, enter. Okay, now again the first step is to define our state, right? So define our state. Okay, now first class a support state of type dict. Okay, and this consists of messages in the form of list, sorry, form of list of string, right? And then for our issue type, like what kind of issue we'll consider, simple literal, where I'll pass those issues. So billing issue type, right? It should be colon, right? So billing, then another one would be technical, and except that we'll have unknown. Okay, that's it. I'll run this cell. All right, then we need to define our nodes. So define nodes. Okay, and I'll just simply copy this from here. Here we go. I'll copy this. I'll come over here. I'll paste this. So here we have our two nodes as our greet node and our classify issue node. So in our greet node we are printing hello, I am a support bot and what issue can I help you with. And this greet node is kind of returning, like not kind of, is returning this support state with the updated value. Okay, and for our classify issue node we'll first take the message of the user, and if in that message we have a word bill, and then we'll choose the billing, like then we'll update the state issue type literal up to billing. If we have error or crash or like this kind of words, we'll be having a technical, and except this three word it will be an unknown. Okay, That's it. Now, after defining these nodes, we need to define those tools. Now you could see we have our tools right here. So I'll copy this, I'll paste it over here. Tool of billing tool and the technical tool, and there should be another tool for our unknown. So def, let's say a tool of fallback tool, which consists of support state. Okay, and this will also return our support state. Okay, colon, then here I'll print this simple thing with question mark, this one. Okay, so print sorry, say sorry, could not understand your issue. Okay, all right, and then we'll simply return our state, run this cell. All right, so we have defined our state, our nodes, our tools. Now we need to define our graph. So build the graph, right? All right, so as we have done earlier, so graph would be call our state graph, and we need to pass our state, so support state, right? Then we need to add all these nodes that we like, how we want to structure our workflow. So graph dot add node, so this one, add node, and the first node that we'll use is this greet node, right? So we'll name it greet node, but for giving it a name, so that we can use it multiple times without using this greet node, we'll be giving it a name as greet. Okay, now again, after the greet node, we need to add another node as classify node for our this classified issue. Okay, and then graph dot another one where we need to add our billing node, so billing support, and here we'll pass our billing tool, and I'll just accept this auto suggestion. Okay, tab suggestions, so technical support and fallback tool, right? Okay, now we haven't added our entry point and our endpoint or our edges, so for that graph dot set entry point, so set entry point, here I'll add our greeting node, and then we'll add a edge. Okay, so graph dot will add a edge, so we'll add this edge where we'll pass greet, and we'll add the edge between greet and classify, so greet and classify. All right, now from classify, like where you should go, right? So we need to add edges from tool or fallback. Okay, like after classifying the user's query, like how we should end it, right? So for that, again, simple graph, we'll add the edge, we'll add our edge, and here we'll pass our billing tool, so billing support, sorry, billing support, and here we'll pass end. Okay, then I'll just copy this one and I'll paste it 2 times, and I have to change this to our rest of 2 nodes, our rest of 2 edges. So take support, and another one would be simple fallback. Okay, enter. But the problem is we haven't really decided how my, like, what will be my routing logic, because I have these three edges, right? So I have these 3 doors. So I have to add the logic so that my application understand where I have to go. So between these 2 cell, I'll add another cell, and here we'll add a new function as, let's say, route logic. Okay, which again will take state of support state. Okay, and which will return a string. Okay, now here we'll return a value. Here we'll simply return, like, if this classify node chooses billing, then what path it should take. If it chooses technical, then what path it should take. Okay, so if the classify node chooses billing, it should take billing support. If it chooses technical, it should choose technical support. For unknown, it should choose fallback. Now, which kind of information are these? These are the state information. So state with issue type. Okay, and it's saying some error. Why is that? String literal is unterminated. All right, this one, right? All right, okay. Then, as we have to add a conditional edges for that, so I'll use add this conditional edges, where I first have to pass my classify node. Then I need to pass this particular route logic node, not node, a function, this route logic. Then I need to pass that billing method. Okay, so billing support, billing, technical support, technical, fallback, unknown. That's it. Fallback, unknown. Okay, fallback, I can use fallback as well. Okay, so billing support should be billing support. Okay, not the billing. Then technical support should choose technical support, and fallback should choose fallback. Right, I'll run this cell, I'll run this one again. Then we need to compile. So compile, right? Here I'll use this runnable graph, where I'll simply use graph dot compile. Okay, there is some error. It's saying found age starting at unknown node take support. Alright, so let's see. Alright, this one, this should be technical support. Run again, take support. Alright, technical support. Here we have technical support. Let me run this from this cell again. This one, that should work. Alright, okay. So now I need to run the graph. Now I have to run the graph to check if it's working or not. Okay, so first let me just simply print. As I said earlier, that it would be a simulation of all this concept of LangGraph. Okay, so what kind of simulation I'd want? Let me, here I'll test for a billing issue. Okay, so billing issue. All right, so as we need to check all the steps of my LangGraph. So for that I need to enable the stream true so that it shows us each and every step. Okay, so in a stream, if I take my runnable graph, so the runnable graph, then if I use the stream, and here I need to pass the message. So the message, let's say I have a billing issue and issue type, let's say I don't know the issue type. Okay, then what it should do? Then for that I need to iterate and show each step to see that how my graph is working. Okay, so for step in stream, what I'll do, for node name and let's say for node name and node output, in our step dot items I'll simply print with f string of node of our node name. Okay, so node name, and another one is, let's say, our state. So our node output. Alright, I'll run this, and here you could see our simulation of billing issue. Hello, I'm SupportBot. What issue can I help you with? Node greet, because the first node that I am getting into is my greet node. Then so and at the time of this node greet, the message I have is this one message. I have a billing issue type unknown. Now the second node is my classify. Now as I said earlier that my state would be updated in each and every node. So in my node classify, my state been updated and my issue type been changed as billing, because as per this logic, see, as I have a bill word in my query or the message, it chooses the billing path. Then it has shown me, okay, all right, redirecting you to the billing team, not billing support. Okay, so that's how your LangGraph agent would work under the hood. This is how you can easily use all those LangGraph fundamental concepts to practice your LangGraph skill. Okay, so yeah, thanks for watching. So now let us print the workflow of our graph. Okay, so for that again I'll use Python. From IPython I need to import image and display. Right, then in display I'll use my image function, under which I'll use that particular runnable graph dot, I'll use get graph. So get graph, then simple draw marmot png. So draw marmot png, that's it. I'll run this. Okay, it's saying there is an error. IPython, oh sure, it will be IPython dot display. Enter. Here we go. You can see from start node, our first node, like our entry node, will be our greet. Then we have a node classify, from where we have these three conditional edges. So as per user's message keyword, we are directing our next path. Okay, and yeah, and thanks for watching, and we'll be building multiple industry based project videos with LangGraph, fast API and all those things. Okay, so yeah, thanks for watching.